Okay, now let's take a look at just a couple basic facts about series circuit. So one of the things we look at is we want to answer the question, if one light bulb in a series circuit goes out, what happens to the rest? Do they stay lit or do they go out as well? So to figure this out, we've got to think about the arrangement of the light bulb. So normally we've got our circuit, our current is leaving the positive terminal of the battery, and then it's flowing through each and every light bulb, and then it comes back through the battery, gets more energy, and then keeps going. If any of these light bulbs go out, so let's just say even if it's this last one goes out, the problem here is that we have broken the circuit. So it's like we've got a hole in the circuit right here, and our circuit will look kind of like this. We'll just have a gap in there. Okay, and so if we have a gap, we do not have a closed circuit, and that means that current cannot flow. Okay, so if one light bulb goes out in our circuit, then that means that all the others go out as well. Okay, and that's because there is no path for the current. So in order for current to flow, we need a continuous path from the positive terminal of the battery all the way back to the negative terminal. Here, that path is broken, so we do not have a complete circuit, and those light bulbs will not light. It's the exact same idea as if we have a light switch. So when you turn the light switch on and off in your house, it's basically like having a break in the circuit here. When you close the light switch, or flip the light switch on, you complete the circuit, and now your light bulbs all turn on. And then when you flip the switch to off, you are breaking the circuit right here, and then all of those lights go off. Okay, so the next fact that we want to look at has to do with adding resistors to a series circuit. So let's say we've got a circuit in series, we've got a particular battery, and we've got some resistors. And let's just say we add another resistor to the mix. And we want to know, is our equivalent resistance going to increase, decrease, or stay the same? And will the current through the entire circuit increase, decrease, or stay the same? And so to figure that out, I think it's easiest if we look at an example problem. Now, you can go ahead and write out this whole example problem on your note sheet. I would highly recommend at the very least working through it with me, because it's a really nice way to demonstrate what happens when we add an extra resistor. So I have two series circuits here, one that has 2 resistors and one that has 3 resistors. Just to make things super easy, I gave everything the same resistance. Okay, this will still work whether all of these have the same resistance or not. Okay, and so both of these have a 30-volt battery. All of the resistors are 5 ohm resistors. So in order to figure out the equivalent resistance, remember in series, equivalent resistance is just the sum of all of the resistors. So in this first one, we just take R1 plus R2, 5 plus 5, and that gives us 10. So our equivalent resistance in the first circuit is 10 ohms. If we take a look over here to get our equivalent resistance, now we are adding up the resistance of 3 resistors, R1 plus R2 plus R3. 5 plus 5 plus 5 gets us 15. Okay, the reason for that is because all of the current has to go through every single resistor. So all the current goes through this 5 ohm resistor, and then all of the current goes through this 5 ohm resistor. When we add a third resistor, now all the current has to go through yet another resistor. So as we add resistors, we increase the equivalent resistance. So equivalent resistance increases in a series circuit. Let's take a look and see what the impact is now on the current flowing through the circuit. So I already said that all of the current that flows through the battery is going to flow through each and every resistor. But look at what happens when we increase the overall resistance of our circuit like we did here. Okay, to figure out the current that is going through our circuit, we're just going to go ahead and use Ohm's law to figure that out. And so remember, Ohm's law tells us that voltage, excuse me, equals current times resistance. And so to get our current, we're going to take our voltage divided by our resistance. So in both of these circuits, we have the exact same voltage, but we have different equivalent resistances. This is an inverse relationship, so the greater the resistance, the smaller the current. Okay, so here 30 divided by 10, that is going to get us 3. But here 30 divided by 15 is going to get us 2. So when we add another resistor, we're decreasing the amount of current that can flow through the circuit. So here we could have 3 amps flowing through the circuit. When we add another resistor, now only 2 amps can flow through the circuit. And if you want to fill in the rest of this table, you are absolutely welcome to. So remember, in series circuits, our current is the same through the battery and through every individual resistor. And then just for fun, let's go ahead and figure out the voltage drop across each. So we take current times resistance, 3 times 5, and that gets us 15. Okay. Notice these are exactly the same. That's only because the resistors were exactly the same. If one of these were like 3 and the other one were 8, then these would be different numbers. Okay, but 15 plus 15 gives us 30. Over here, 2 times 5 is 10. And so again, I have the exact same voltage drop only because I have the exact same resistance in each of these. And 10 plus 10 plus 10 is going to give us 30. So we can see in this example, by adding a resistor, we decrease the amount of current flowing through the circuit. We also decrease the voltage drop across each individual resistor. So even though all of the current flows through each and every resistor, because there's more total resistance here, we have less current flowing through the circuit than we did over here with only 2 resistors. So as we add resistors to a series circuit, equivalent resistance increases and the current through the entire circuit is going to decrease.